Real numbers. Proof of irrationality of few numbers. Objectives. Theorem on prime factors of a square number. Proof of irrationality of few numbers. Consider a square with a side length of positive integer. The length of the diagonal of the square is an irrational quantity. Since the general formula to calculate the length of the diagonal is a root 2, and root 2 is obviously an irrational number. Pretty interesting to think that we will never be able to measure the length of the diagonal of a square even if we calibrate a scale with infinite divisions. The straight line is right in front of our eyes, but no way to say exactly what its length is. Let's learn to prove the irrationality of given numbers. A number is called irrational number if it cannot be written in the form p by q, where p and q are integers and q not equal to 0. And non-terminating and non-repeating decimal numbers are irrational numbers. Theorem. Let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. Proof. Using fundamental theorem of arithmetic, we can write a is equal to p1 into p2 into p3 and so on until pn, where p1, p2, p3, so on, pn are primes not necessarily distinct. Then we get a square is equal to p1 multiplied by p2 multiplied by p3, so on, pn, whole multiplied by p1 multiplied by p2 multiplied by p3, so on, pn, which is equal to p1 square into p2 square, so on, pn square. Here we observe that p1, p2, p3, so on, pn are the only prime factors of a square. Given that p divides a square implies p is one of p1, p2, so on, pn, implies p divides p1 into p2 into so on, pn, implies p divides a. Therefore, if p divides a square, then p divides a, where p is a prime number and a is a positive integer. Illustration 1. Prove that square root of 2 is not a rational number. We prove this by method of contradiction. Suppose square root of 2 is a rational number. Then we write square root of 2 is equal to a by b, where a, b are integers and b not equal to 0, having no common factor other than 1. Now, squaring on both sides, we get square root of 2 whole square is equal to a by b whole square, implies 2 is equal to a square by b square, implies a square is equal to 2b is equation 1. Which implies we get 2 divides a square implies 2 divides a, implies a is equal to 2c for some integer c. Squaring on both sides implies a square is equal to 4c square is equation 2. Now from 1 and 2 we get 2b square is equal to 4c square, implies we get b square is equal to 2c square, implies 2 divides b square implies 2 divides b. Now 2 divides a and 2 divides b implies 2 is a common factor of a and b. This contradicts our assumption that a and b have no common factor other than 1. So, our assumption that square root of 2 is a rational number is wrong. Therefore, square root of 2 is an irrational number. Illustration 1. Prove that square root of 2 plus square root of 3 is irrational number. Solution. Suppose that root 2 plus root 3 is a rational number, say x. Then x is equal to root 2 plus root 3. Implies x square is equal to 2 plus 3 plus 2 root 6. Squaring on both sides implies x square is equal to 5 plus 2 root 6. By rearranging the terms, we get implies x square minus 5 whole by 2 is equal to root 6. Here we observe that x square comma 5 comma 2 are rational numbers. So, x square minus 5 whole by 2 is a rational number. Implies x square minus 5 whole by 2 is equal to root 6 is a rational number, which is a contradiction of the fact that root 6 is an irrational number. So, our assumption is wrong. Therefore, root 2 plus root 3 is irrational number.